let's suppose that we have a plane somewhere out there in the three-dimensional space, and on that plane we have a point, and I'll just be, just a generic point, x naught, y naught, z naught, and we have a vector that's perpendicular to that plane. I'll call it n for normal vector. Now let's suppose that we want to figure out an equation for that plane. Okay, so here's how we proceed. Let's just consider another point on that plane Q, and we'll just call it x, y, and z. This is just an arbitrary point on the plane. And let's think about a vector with the initial point at P and the terminal point at Q, like this. Now, what we can do is we could put that vector in component form, like this. And you notice what I've done is I've just taken x minus x naught, y minus y naught, z minus z naught. Because that's the way we do it. We take the terminal coordinates and subtract the corresponding initial coordinates. Now, let's also just consider this vector n to be a, b, and c. Okay, so it's a, b, c. Now, because the plane is perpendicular to n, PQ is also perpendicular to n, because PQ, remember, those are just 2 points on the plane that we made a vector out of, right? We made a vector out of these 2 points. Therefore, this vector must be perpendicular to this vector. N is perpendicular to PQ. So the dot product should be 0. It will definitely be 0, right? So here's what we've got. We've got A times x minus x naught plus B times y minus y naught, see? Plus C times z minus z naught. See, right there. So there you have it. There's an equation for a plane. The particular plane that has a normal vector of ABC and is passes through the point x naught, y naught, and z naught. So let's look at an example. Let's suppose that we want an equation for a plane that contains 2, -3, 7, and is perpendicular to 4, 7, -2. I put it in linear combination here, but still, that's the normal vector. Well, here's what we do. We just write it, right? So notice the 2, okay, it goes right here, and then x minus 2. I mean, the 2 goes right here. The 4 goes here, I'm sorry. So we have 4. Notice right here is the 4 from the vector, and then x minus 2. Then we take the 7, put it there, and then y minus a -3. So look, y minus a -3, those two minuses make a plus. See that negative, so you get a plus here. And then -2 right here, z minus 7. There's your equation. Now what we can do is we can simplify it a little bit, clear the parentheses, and add like terms, and we get 4x plus 7y minus 2z plus 27 equals 0. Yeah, there's our equation for this particular plane that contains this point and is perpendicular to this vector. There. Now let's look at another example. Let's find an equation for the plane that contains the points P, Q, and R here. Now, what we need to write an equation for a plane is a point and a normal vector. A point on the plane and a normal vector. Well, here we're blessed with 3 points. We don't more than what we need, but we don't have a normal vector. Well, we can find a normal vector because what we can do is we can make vectors out of these 3 points. I'll make a vector PQ. See? 3 minus 1 is 2. 7 minus 4 is 3, and 6 minus 2 is 4. There's the vector PQ. And then I can get a vector PR. See? P, and there's R. 2 minus 1, that's 1. 8 minus 4 is 4. And 3 minus 2 is 1. So I've got 2 vectors now. So you might say, well, what good does that do? Well, when we have 2 vectors, these 2 vectors are parallel to this plane, I can find a vector perpendicular to these 2 vectors, orthogonal. I can find an orthogonal vector, and remember the way we do that is with a cross product. So I set up a cross product here. PQ cross PR and we get the vector negative 13, 2, and 5. Now we have a normal vector. We have 3 points and we have a normal vector. Therefore, I can choose one of those points and use it with this normal vector to get my equation. Now I'm going to choose, I'll just choose point P, just because it's the first one up here. You could choose any one of these 3 points and you would get the correct answer, the correct equation. You would get an equation that describes that plane. So let's see what we've got here. We've got negative 13, I put it there. Notice where the vector components go, negative 13, 2, and 5. So we got negative 13, x minus 1, see that one, 2, y minus 4, and 5, z minus 2. Now if we work this all out, we get negative 13x plus 2y plus 5z, and then minus 5 for the final answer. And that is how we can get an equation for a plane.